Welcome to The Explainer. If you've been paying attention to enterprise architecture lately, you know that the entire game has fundamentally changed. We are no longer just dealing with software that performs isolated, predictable tasks. No, we're dealing with interconnected, autonomous systems that operate completely outside of traditional human supervision. So today, we're diving into exactly how we secure these environments. We've got to figure out how to maintain structural integrity and compliance when the machines themselves are the ones making the big decisions. It's a high-stakes shift from manual compliance to real-time AI governance, and in today's May 2026 landscape, it's absolutely crucial.
Here's our roadmap for today. 1. The silent AI threat. 2. Beyond static compliance. 3. Stopping algorithmic collusion. 4. Hard-coding AI guardrails. And 5. Bridging GRC and engineering. Let's jump right in.
Section 1. The silent AI threat. Unseen risks in machine-to-machine ecosystems. So we really need to address this new, practically invisible danger that's popping up in global supply chains as human oversight gets swapped out for automation. I want you to consider this critical question for a second. What actually happens when machines negotiate with other machines totally without human oversight? Just think about your own global supply chain. We spent years optimizing for efficiency, right? We deploy procurement agents to source materials, negotiate contracts, and execute trades in literal fractions of a second. It's incredibly efficient. But when you remove the human from the loop in decentralized procurement, you're also stripping away the human intuition that catches those subtle, emerging risks. When two highly optimized AI agents interact, their singular goal is to maximize their programmed objective. And honestly, that can lead to some highly unexpected and legally perilous behaviors. Which brings us to the core problem here: algorithmic collusion. This is the silent threat of emergent price-fixing behaviors that happen when autonomous agents negotiate in decentralized procurement. See, autonomous agents can unintentionally, or sometimes even intentionally, depending on their optimization algorithms, engage in price-fixing in global procurement without us even knowing. They aren't meeting up in some smoke-filled backroom. They're simply interacting mathematically in the market. But the result? The result is exactly the same: massive antitrust risk. As a strategic leader, if your systems collude, your company holds the legal liability. We have to dismantle this threat, and to do that, we need a complete paradigm shift in how we approach governance.
All right, Section 2. Beyond static compliance. The failure of manual oversight.
There is such a stark contrast between the theoretical frameworks of the past and the dynamic code we desperately need today. First, you've got the old world, static compliance. This is where we relied on periodic manual audits, theoretical ethics discussions, and paper-based security frameworks like your traditional SOC 2. But guys, these are just too slow. They only check if you were compliant yesterday or maybe last quarter. Then you have the new frontier, dynamic governance. This requires programmatic safety layers, functional code that actually acts as a barrier, and the real-time interception of data. It's no longer about whether you have some ethics policy sitting in a PDF file somewhere. It's about whether that policy is literally written into the executing code of your environment.
Manual oversight is dead. It really is. And enterprise leaders absolutely must adopt structural integrity to mitigate these massive antitrust risks. By May 2026, the industry has definitively shifted. We've moved way beyond just talking about theoretical ethics, and we are now facing the urgent, immediate need for programmatic safety layers. If your organization is still treating AI governance as a yearly audit, you are operating with a massive blind spot. You need systems that secure this high-stakes world of algorithmic oversight natively, operating at the exact speed of the machines themselves.
Moving to Section 3. Stopping algorithmic collusion, bridging efficiency and antitrust risk.
Let's look at how we practically deploy these real-time monitoring protocols. Here's how this automated quality assurance actually works in the real world. Step 1. Your autonomous agents kick off a decentralized negotiation to source a part. Step 2 is where the magic happens. Real-time monitoring protocols instantly intercept that negotiation data. Step 3. The dynamic governance systems analyze the data stream to detect any emergent collusive behaviors or price-fixing patterns well before they ever materialize into a contract. And finally, Step 4. Programmatic enforcement ensures airtight compliance before execution. The transaction is either blocked or modified instantly if it violates antitrust rules. This is exactly how you bridge the gap between incredible operational efficiency and strict legal compliance.
Section 4. Hard-coding AI guardrails, regulating the inference pipeline. Now, it's not just procurement agents we have to worry about. It's also the large language models operating everywhere throughout the enterprise.
The inference pipeline is the operational pathway where large language models actually process data. You simply cannot treat an LLM as a black box where you just cross your fingers and hope the output is safe and compliant. You have to treat the inference pipeline exactly like a physical supply chain. Think about it. In a physical factory, you don't wait until a car is driving down the highway at 70 miles an hour to check if the brakes work, right? You have automated QA checkpoints right there on the assembly line. Well, we need those exact same real-time automated checkpoints for our data as it flows through the large language model.
Here is your playbook for building automated controls for large language model outputs. First, move beyond manual oversight completely. Humans simply cannot read fast enough to check every single LLM output. It's impossible. Second, engineer systems to intercept and validate responses in real time. Third, map your automated policy enforcement directly into the pipeline. Fourth, and honestly this is the most critical step, transform abstract ethics into hard-coded constraints. If your policy says do not share PII, personally identifiable information, that shouldn't be a polite suggestion. It needs to be an impenetrable technical barrier in the code. This is how you ensure structural integrity across every deployment in your continuous ecosystem.
Finally, Section 5, Bridging GRC and Engineering, the next generation of automated governance.
This brings us to our final operational mandate. We absolutely must unite legal liability with technical automation to secure this high-stakes world of algorithmic oversight. Historically, the legal team and the engineering team spoke entirely different languages, didn't they? The compliance team worried about antitrust risk and SOC 2 audits, while the engineering team worried about pipeline efficiency and speed. Well, to survive in this new era, those two separate worlds must become one. Governance has to become an engineering discipline. You must act as the strategic leader who translates static compliance into scalable architectural solutions that govern rogue LLM outputs and autonomous agents alike. You are no longer just auditing, you are architecting programmatic safety layers.
I'm going to leave you with a pretty provocative question to evaluate your own automated governance readiness today. Are your enterprise compliance frameworks moving at the speed of manual audits, or are they moving at the speed of autonomous machines? If it's the former, it's definitely time to start hard-coding your guardrails. Thank you so much for joining me on this explainer as we dove into the technical frontier of real-time AI enforcement.